Assalamualaikum warahmatullahi wabarakatuh, and a very good morning. I bid to Dr. Lui and Dr. Nurain. So today our group 4 is going to present about the analysis of sediment pollution by using PCA analysis in the SPSS. So for the introduction to PCA, Principal Component Analysis (PCA) analyzes a big set of variables and searches for a solution to minimize the data using a smaller amount of elements or components. PCA can maintain the majority of a dataset's variance by using the mathematical method by decreasing the data dimensionality. The heavy metal data obtained were keyed into the SPSS software, and the Principal Component Analysis (PCA) was run. By using the Principal Component Analysis (PCA), the data were successfully reduced and the heavy metals grouped according to their respective groups. The PCA has identified that the heavy metals listed in the slide are the most significant parameters.
Now I will show you guys how to perform the PCA using SPSS for this data. So for first step, you need to copy all the data here and you paste it in the new sheet as like I show you here what I did, because we don't want to disturb the initial data. So we want to prevent any accident for that. So then next we'll be moving to the SPSS. We go to the open the SPSS and go to the variable view, and at here we will insert all 12 heavy metals from the data here, aluminum until the cadmium, so that we can interpret the data. And at here I can show here what I did. So I've inserted all the data, all the heavy metals from the aluminum and the cadmium, and I changed the decimal into 3 decimal points, and also I changed it for scale for all heavy metals. Like then, I will start to copy all the data here from here until to the end of the station and heavy metals, which is here. Okay, then I will copy all of this and I will paste it in the data view at here like I did. It's like this. Okay, then we need to make sure the data is there and there is no blank or zero data in our SPSS. So then we can perform the PCA. So we go to analyze, go to dimension reduction and vector. Then all variables from here, originating from here, then we need to transfer into these variables variables box. Okay, then we go to descriptive. We need to tick under statistic, we need to tick initial solution, and under correlation we need to tick coefficient and KMO and Bartlett test of sphericity. Then we click continue. Under extraction, we're gonna need for the method, we're gonna choose the principal components, and under analyze we're gonna tick correlation matrix, and under display we're gonna tick the unrotated vector solution and scree plot, and under the extract we're gonna tick based on eigenvalue. Then we click continue, and under rotation there will be none, and under option we're going to tick exclude case pairwise under the missing values, and under coefficient display format we're gonna untick for both of it. Then we click continue, then we can click OK, and the result is shown like this. Okay, this is the result output from the PCA that we have performed. So we need to know and verify the data, is it suitable for the PCA or not. So for that we're going to look at the KMO and Bartlett's test. For the KMO value, it need to be higher than 0.6 and the significant value need to be lower than 0.05 in order for us to verify the data is suitable for the PCA. So as you can see here, the result shown as 0.761 for the KMO value, and the significant is 0.000. So it shows that our data is suitable for the PCA. Next, we need to know how many components that we need to extract from the output. So at here, we go to the total variant explain table, and for the column initial eigenvalue under total columns, we need to choose the eigenvalue which is higher than 1. So from this table, we know that there is two components show the value of eigenvalue higher than 1. So there will be two components that we will extract from the data. Then we go back to the SPSS. Then we're gonna click analyze back, go to the dimension reduction and factor. So we go to the extraction. We changed under the extract. From the earlier we take the base on eigenvalue, but now we're gonna take fixed number of factors, and the factor to extract is 2. Based on the eigenvalue that based on the component that we choose, which is 2. So we're going to click continue, and for the options, for the rotation, we're going to pick method. Under the method, we're going to tick Varimax, and under the display, we're going to tick rotated solution and the loading plots. Then we click continue and we click OK. So the output is like this. So we have show the GAMO and the Bartlett test, and then we go to the total variant explain. There is new column which is the rotation sum of squared loadings. Then we go to the components matrix, rotated component matrix table. As you can see here, there is two components have been extracted, and the components for the 12 heavy metals has been shown here. So as you know, the data that below than 0.3 is identified as weak, and we need to eliminate the data that is below 0.3. To do that, we go back to SPSS. We open analyze, dimension reduction and factor, and under options, we choose the coefficient display format, and we take the suppress small coefficients and the absolute value below than 0.3. We will insert the value 0.3 because the range from 0.3 and below is referred as weak. So we need to eliminate that. Then we click continue and we click OK. Then the result will be shown like this. Okay, this is the new rotated component matrix table that we have here. It shows a few values have been eliminated. So we will interpret the outcome. So we need to copy this table and paste it in the Excel in our new sheet. We put it below and like this. And also we need to copy the rotated component matrix, the new rotated component matrix here, and we paste it in Excel like what I did here. So we will delete the first two columns, two rows, and also the two last rows, and we will delete it. So then we will interpret the result. So we need to choose the first column. So the first column we will sort from the largest to smallest, and we copy this one. This is the data that we get. I'm sorry. We're going to copy, then we're going to paste it here. Then we do the same thing to the second column. So from Z to A, and there is the data we need to copy and paste it below. So as you can see here, Ni, Mn and zinc show the two data from the two columns. So we need to eliminate 3 of it because the data we choose from the two columns is 0.766, 0.787 and 0.558, which is higher than this value. So this value will be deleted. Then as you can see here, Ni, Mn and zinc is repeated from the first upper part of the table. Then we need to delete also this because it's repeated from the upper part of the table. Then as you can see here, there is only 11 data instead of the 12 data we have. So how we want to know which data is missing? So we need to highlight this first because we want to differentiate between the other data. So we're going to perform the same step as you do at this table. We need to perform in this table so that we know which data is missing. Okay, as you can see here, problem until the zinc already here. Then we're going to choose this data. We're going to copy it and paste it here. Then we go to Fe aluminum and copper. So Fe aluminum here and Fe aluminum here. Then we copy this data because the data is not there. Copy and paste. Then for the Cu, we copy this one and we paste it here. Okay, then as you can see, there is one heavy metal missing, which is cadmium. So for this one, we're going to copy it and we put it here. Alright, so as you can see, this is the final output of the table that we are using right now. So from the table, we're going to interpret the output into the words. So as you can see here, I already interpret the output. So by using the PCA applied to the whole heavy metals, which is 12 heavy metals, comprising 9 monitoring stations, and we show also the KMO value, which is 0.761, and I get it from here. From the KMO embedded test, which is 0.761, and the Bartlett test of sphericity reached statistical significance, which the value is below the 0.05. So for the principal component analysis revealed the presence of two components with eigenvalue more than 1, explain 47.96% and 31.484%, and this data will be choose from here. This one, 47.963 and 31.484. And the two component solution explain a total of 79.447. That value we obtain from here, cumulative, and also same with the rotation sum of square for both cumulative. Then the PC1 accounted of 47.963% of the variance, and the PC2 accounted for the 31.484% of the data. So this is how you interpret the output from the PCA analysis.
That's all from our group. Thank you for listening.